Here we have a short page of notes looking at projectile motion in comparison to two other types of motion and reconciling the differences or similarities between the two. Now, the regular projectile motion is, of course, the green projectile here going through its projectile motion, fired from a cliff horizontally and impacting the ground down here. Well, the other type of motion we're going to compare it to is a cannonball that is dropped. So if we have a cannonball dropped exactly at the same time that the green cannonball is fired sideways, what we will see is gravity will affect both the same. So the acceleration due to gravity, that negative 9.8 meters per second squared, right, is the same for our brown one or for the green one. So the only difference, in the absence of air resistance, the only difference is that the green one is going to land downstream. So please get into your notes. They love this question as a multiple choice question. They will hit at the same time. So even though that cannonball is fired super fast, unless it sprouts wings, that green one, unless it sprouts wings and is going to stay up in the air longer for some other reason, gravity alone dictates that they hit the ground. A and B hit the ground at the same time. The other question that you will sometimes see is talking about the path difference between the no gravity flight of a cannonball and the actual motion. And as you can see here, our blue cannonball would be what the cannonball would do if we had the ability to flip the gravitational light switch off and shut off gravity. So if the instant the cannonball was fired, you flipped your gravitational light switch off and shut gravity off, it would just go sideways with whatever speed in the x direction that it has. Now, the speed in the x direction does not change whether it's the green one or the blue one. So they stay right on top of each other in terms of the x direction, the blue on top of the green. But the path difference, so typically what they'll ask in a multiple choice question is for you to describe how this path, this delta y distance, is changing in the problem. Well, it is changing according to our quadratic. Delta y equals v initial in the y direction, which in this case is 0, right? Plus 1/2 at squared. So it's changing according to the quadratic based on negative 4.9 t squared. So I added this page of notes because they love test banks love this question. And it's not always intuitive to understand these two motions, but I think after having talked through it and understanding our projectile motion and two-dimensional motion to this point, we are in good shape. So we will move on.